Good morning, this is Professor Todd Elliott, and in this video lesson we will look at an overview of industrial communication cabling methods, and be sure to look at my professor notes, which has a lot more written material to support this. So anyway, continue on. First thing we're going to look at is the twisted pair cable. That's by far the most common. And here we have unshielded cable. An example would be telephone wire. Now, telephone wire has more conductors, of course, but it's still typically unshielded, so it's still applicable. So this image, you see we have two wires, and inside the wire they're going to be twisted or wrapped around one another, and that's to minimize crosstalk and external electrical interference. But there is no braided shield. Let's pull up my pointer here. So here we have just the two conductors. This is obviously the PVC or whatever it is, the jacket. Okay, there's no braided shield. So if the application is appropriate for unshielded cable, then two of the primary advantages are it's very low cost and it's highly flexible. You can bend it into sharp bending radiuses and tight areas, but it doesn't have any electromagnetic field protection from noise, so that could be a disadvantage. So anyway, that's unshielded cable. And by the way, this is normally referred to as unshielded twisted, we draw here, pair, unshielded twisted pair, UTP cable. That's kind of what we're talking about on this slide. Oops. Okay, shielded cable. Shielded cable is known by the acronym shielded twisted pair. Okay, and again, the twisted pair, it just means that inside the jacket itself, then the wires are twisted, wrapped around one another for to reduce interference. Notice here we have a drain wire. Okay, so or sometimes called the ground wire or a drain ground wire. That normally you're going to connect to a clean, note the word clean, ground, which may not necessarily be the factory facility earth ground, which is usually noisy. Also has a foil shield, and that foil shield you can see here is wrapped around the conductor. So the conductors are twisted together with a certain amount of twist, which is something the manufacturer can control. And then an overall foil shield. Sometimes it's a braid, it's like a mesh, is applied. Could be either one. So that's your basic shielded cable. It's also possible to get the conductors with individual shields for higher levels of noise immunity and eliminating crosstalk. That makes the cable bulkier and is definitely more expensive, and it's not always necessary, but it is an option. Okay, so anyway, so that's basic shielded cable. So if you're going to work in a commercial pipe building or a factory particularly, almost certainly most, if not all, the cabling will be, communications cabling will be of the shielded type, because there's electrical noise everywhere, which they want to try to minimize. Okay. So one thing that you're eventually going to run across is something known as the ground loop. And to give credit where credit is due, this is where I got it from. And I encourage you to go to their website. There's a lot of good information on there. And anyway, so what you're going to see, so I'm going to change my pointer color. Here, change it to, let's go purple. Okay, is a ground loop. And a ground loop theoretically should not exist, but it does quite frequently. And it's a case where there's a difference of potential or a voltage between two ground points. And that can be caused by too small of a ground wire, poor connection, bad wiring practices, just a whole host of things. And the trouble is they can be very difficult to diagnose and troubleshoot because the problem will generally be intermittent. So a piece of machinery or equipment or a controller or something may occasionally act kind of flaky or weird, but not all the time. Definitely, I would suspect a grounding problem. So something you want to try to minimize, hopefully eliminate during the initial installation. So here we have a 24 volt DC battery. We have level transmitter number 1, and we have level transmitter number 2, and it's monitoring the level of some sort of liquid in a tank or a vat or something. Doesn't matter. And anyway, its output is going to this meter, to a display, and likewise, this transmitter has its own display meter. Okay, so notice right here, okay, the power supply for the meter is tied to ground, and the power supply for the meter is tied to ground. But those two grounds physically are separated. Okay, I don't know how far they're separated, but they're separated. They're not to the same point. Right? If you recall our work in the laboratory with the oscilloscope, is that we always had you connect the black scope clips, the ground clips, to the same ground point. And the reason is we wanted you to not have a ground loop, which can occur if you have it at two different points. Okay, so that's why we had to do that. Anyway, so if you go to the site, and I recommend that you do, and I just found them online. They say that they're assuming that there's a poor ground connection here. Maybe the terminal screw is loose or some other problem, right? And there's a difference of potential between that point there and between that point there. And obviously, this should all be zero between them, but it's not. Okay? And you can have many volts of potential difference between two ground points, depending on how severe the case is. So anyway, so because there's a difference of potential, you see here where they have a ground current flowing, they call it I ground, which is between these two ground points, and that's what they've sort of highlighted or indicated by this dashed rectangle here. Okay, so ground loose, something you're going to run into. It's just generally caused by poor wiring practices, and something you definitely want to be on the lookout for, and definitely want to stay away from if at all possible. Okay, just a couple wiring diagram samples. Again, I just found these online. This particular one is from Omega. Omega is a major equipment manufacturer, so have a look at them. Just go to omega.com. Okay, and again, I just was searching for transducer wiring diagrams, and this is what came up. So anyway, they have a transducer here, some sort of sensor, doesn't matter what it does, and we have a DC power supply right there. It's providing DC voltage, which simply they call the excitation voltage. Okay, so it's the power supply, and then the signal leads are coming back out like this. Okay, to the instrumentation, some sort of display. Okay, so notice here we have a plus to a minus here. So this is certainly a differential type transducer, which is the preferred way. If you go back to your notes on op-amp input modes, there were single-ended, common mode, and differential. Common mode is generally electrical noise, practically, by the way. Differential mode is the preferred method because it greatly eliminates or reduces the impact of common mode, i.e. noise, unwanted signals on your control cable. Okay, so all these cables will certainly be, conductors will be in one cable. We want this to be a shielded cable, properly grounded, to try to minimize electrical interference. Okay. Here's another one. I was just searching for PLC input card wiring. Joe will talk about PLCs with you in industrial control. and likewise next term. But anyway, so notice here we have some sort of a sensor. Okay, we have 3 wires. Okay, we have a red, a white, and a black. Okay, the red's the DC voltage, the black is the ground, and the white is the signal. So this is a single-ended input, and it's coming from a transistor. So last semester in electronics, we learned about current sinking, and also in logic, I guess. So that's going to be a current sinking NPN transistor. So you should be able to understand what that's all about. And it's getting its power through a single control cable, typically want to be shielded, coming from a PLC or some sort of controller input, and this is the terminal strip to make the connections. Okay, down here, same sort of idea, but our sensors now is from a PNP device, and this is current sourcing. Go back to your electronics. We talked about current sourcing. Okay, they're recommending a 2.2K pull-up resistor here. Means it's probably open collector. We didn't talk about that, but a lot of transistor and sensors are open collector. And again, the control cable, it's going to be all shielded, and everything, the power cable is the ground, and the signal comes back to the same input card. Okay, and credit where credit is due. That's where I found that, so please look it up. They have a lot of good information on their site. But anyway, category 5 cable. You've all at least seen this. I may not know what it's called. This is called, generally might be called LAN, local area network, or internet cable. And it's basically what's going to plug into your computer if your computer is hardwired. Okay, and it's usually red, blue, or gray in color, but that doesn't really matter. Okay, so anyway, so I found this online, and again, credit where credit is due. It's a nice picture. That's where I got it from. So category 5, category 5E, and category 6, they're all compatible. The category 5 is the older standard. Doesn't mean there's anything wrong with it. So here they're indicating a through cable or a patch cord, and it's got 2 RJ45 plugs, which is the standard connector. Okay, and I'm sure you've seen them before. Notice that the wire colors, see we have there's a striped orange, and then a solid orange, and then a striped green, then a blue, then a striped blue. Okay, it's meant to be in that order to eliminate crosstalk. Okay, so the orange and the striped orange are a pair, and like the red and the striped red are a pair. And by putting them in the cable, wrapping foil around them, twisting them together, it'll eliminate crosstalk between the conductors. Okay, so Cat 5, again, it's an older standard. Absolutely nothing wrong with it whatsoever. Just to give you a little bit of background, it's also in my professor notes, and I gave you there lots of links to external internet resources. But with the Cat 5, it's generally good up to maximum of 100 megabits per second. The Cat 5E, E just stands for enhanced. It's a little better construction. It probably has more shielding, I'm assuming is the difference. It's theoretically good up to a gigabyte per second. Okay, again, theoretically, depends on the actual installation and how it's wired and the quality of the routers and stuff and the other components, but theoretically. And the Cat 6 is just a little bit better in terms of its noise immunity. It does have extra cost. Is it worth the extra cost? I don't know. It's up to the installer or the engineer to make that decision. But they're all basically compatible. So if you're installing it, you might as well go for the newest standard, unless the price prevents you otherwise from doing so. But Anyway, have a look at my professor notes. There's a little more information in there, and give you some idea, just you know, a little bit about it. But anyway, okay. The last cable type we're going to look at is fiber optic, which has actually been around for decades. It's really not particularly new. There's two major fiber types. One is called single mode, and the other one is called multi-mode. So look at the single mode first. So mode just refers to sort of how the pulse of light travels down the glass fiber. So right here, the center here, that's the actual core. Okay. For single mode, it's typically 10 micrometers or less in diameter. It's very small. And then the cladding, which is sort of optically reflective and optically pure. The idea is to keep the light from, you know, sort of contained within the core. And then this is just simply the outer jacket, and that's just the physical protection. I just want to switch my pen color back to red. Sorry. Okay, good. And anyway, this particular picture I got from Belden. They make fiber and all kinds of wiring, so there's tons of information on there. And but with single mode fiber, theoretically you can go up to 200 kilometers. In theory, there's other factors, of course, but it can be very, very long distance, very, very high speed, perhaps as high as 100 gigabytes per second. You know, ideally, practically may not achieve that, but it's very, very high speed. Okay, so anyway, with single mode fiber, you're going to be using a laser LED source, which is more expensive. So these are going to be used for major communication systems. Your cable companies might very well run single mode. Do you necessarily need its advantages? Maybe not. It sort of depends. But fiber has lots of bandwidth, lots of high speed. Some of the disadvantages are that it doesn't have quite as tight of a bending radius as with twisted pair cable. Also, if the cable for whatever reason is damaged in the field, it's significantly more difficult to repair. You can't just sort of solder it back together. It's much more complicated than that. But anyway, so that's a little bit about single mode. The other type is multi-mode fiber. Multi-mode comes sort of in two standard diameters. One is 50 micrometers and the other is 62.5. Okay, that's the diameter of the glass core. Okay, the jacket here in both cases is 125 micrometers in diameter, and this little thinner part, black part in the center there, that's the cladding. That's again is to keep the light within the glass from leaking out. Okay, so within the multi-mode family, there's two types. There's a step index and there's a graded index. Just a real different way of how the light pulse travels down the core. One thing with the multi-mode is you can't get quite the same data rates or the transmission distance as single mode because the light pulse it degrades, it disperses, or breaks up into different modes, if you like. And at that point, the signal kind of breaks down. So this is good for local area networks, or runs maybe up to a couple kilometers. It's not really applicable for long distance, but the whole system, including the fiber, the transmitters, and receivers, are going to be more cost effective than with single mode. It's a little bit easier to work with if you have to splice it. Hopefully you don't, but if you do, it's a little easier to work with. But anyway, but the two main types are multi-mode and single mode, and so have a look at that. And again, I have more resources in my professor notes for you to follow up with. Okay, fiber optic transceivers. Transceivers simply means the transmitter and the receiver are all in one unit. It doesn't have to be that way, okay? But anyway, so here we have an electrical pulse coming in. Okay, we have some sort of buffer or interface, right, to drive the LED or the laser source. So again, with single mode, it's definitely going to be using a laser source. It has a very narrow pulse width. If it's multi-mode, it could be LED or laser, sort of depending. But anyway, so you get sort of electrical pulses in, and you get light pulses out. Okay, and it travels around through the cable, the whole system, and then comes back into there, into the detector, which is really just a photosensitive LED shining on a transistor type of idea, and then some sort of interface circuit to convert it back to an electrical pulse. So anyway, so that's basically the receiver, and if you're pricing out the system, you have to include that because the fiber is useless without the transmitter and receiver. So it definitely is a major consideration. Okay, types of fiber optic connectors. Again, here's where I get it from. There's tons of information online, and I'm pretty sure this is not even all of them. But if you just look at just sort of these two, okay, this one here is the ST connector. This is the FC. Okay, notice that they look very similar, but they're not. This one here is a twist-on. This one is a screw-on, so it's going to be a more solid connector. They're both good for single mode or multi-mode fiber applications. Okay, for the ST, the recommended general application is for local area networks, and for FC, they're a little better connector, and of course cost more. Data communications, telecommunications applications. And then there's some of the other ones, FC, LC, MU. You don't have to memorize these, okay? But it gives you sort of the typical applications of the different connectors. Okay, so that's basically it. And don't forget to check out my professor notes, and I'll give you a lot more information. And I hope it was beneficial today. All right, thanks. See you all soon. Cheers. Bye-bye.